Well, hello everyone, and welcome to the webinar on artificial intelligence for sustainable mobility. The webinar is arranged by the Finnish Centre for Artificial Intelligence, or FCAI, and supported by the Helsinki Institute for Sustainability Science, HELSUS. My name is Ruotsalainen. I'm an associate professor at the Department of Computer Science at the University of Helsinki, and also a professor member of both FCAI and HELSUS. So we will have today a very interesting and exciting program ahead. So we will be hearing presentations from the industry, academy, and we will have a panel discussion. And then at the end, we will also be hearing about the project pitch related to electronic vehicles. And then first, some housekeeping practices. So due to the very tight schedule and to be able to hear all the exciting presentations, so we won't open the floor for questions by using the microphones, but you are very welcome to ask the questions by using the question and answer tool that you can find from the bottom of your Zoom panel, the Q&A tool there. And then also the whole event will be recorded, and then you will get the recording afterwards. So to get back to the different presentations and discussions. But so we will start now the program, and I will start by talking about sustainability and how artificial intelligence can be used for promoting and enabling sustainability, and especially from the mobility viewpoint. So I will be talking with the title of Artificial Intelligence for Sustainable Mobility. And first I will define what the sustainability really means. And then talking about what are kind of like the challenges related to mobility and sustainability at the present moment. And then I will be talking a bit about how then artificial intelligence can help in creating sustainable mobility. And then talking a few words about our own ongoing projects. So United Nations have defined that sustainable development is the international community's most urgent priority at the moment. And then sustainability is based on three pillars. So whatever development we do, we always have to consider the sustainability from the ecological, social, and economic viewpoints. And in the heart of the goals set for the sustainability by the United Nations until year 2030 are 17 sustainable development goals. And they really demand for very fast actions from the whole international community. And as looking at the development goals, we can see that artificial intelligence has very important part in all of them. So what are then the challenges related to mobility and sustainability at the moment? So there are many, could we say, even violations happening from the sustainability viewpoint. For example, when talking about the present road traffic and land transport. So yearly, 1.35 million people get killed by road traffic accidents. And then 10 million people globally also get injured yearly. And there it has been evaluated that 93% of the accidents are caused by a driver error. So the driver not really concentrating on what is happening. And the road traffic deaths are also the leading cause of deaths for young people, so people below 30 years old. Then also road traffic is very major cause of greenhouse gas emissions. So for example, in Finland, 1/5 of the greenhouse gas emissions are caused by road traffic. And then also we don't have at the moment equal opportunities for accessing transport, not globally and not even in Finland. And that is very heavily related to where people live and their personal traits also. So it's no wonder that the World Health Organization has then set very strict goals for developing the mobility from the sustainability viewpoint and addressing these road transport safety and other issues by demanding that very soon the number of traffic accidents would be halved, and also the possibility for transport, access for transport would be then given for everyone. So what can then artificial intelligence do for sustainability and especially for smart mobility? So when talking about artificial intelligence, so artificial intelligence will revolutionize the mobility system in the future. So we already have the cities equipped with some sensors, and the number of sensors will grow all the time. And the same thing with the users. The users will have different kinds of sensors and mobile devices that they can use for collecting data. And then, of course, when using and developing artificial intelligence methods for analyzing and processing the data, we are able, for example, to optimize routing and thereby free space for other use, and then, of course, get rid of the greenhouse gas emissions largely. Then we are able to, for example, combine different transportation modes, and about that we will hear a lot about when talking about mobility as a service today later. And then we are able to monitor the traffic flow of people and make predictions of how people are moving in the city ecosystems, and, for example, get good advice for developing these cities. And then the future development, for example, autonomous driving, will also, of course, provide a lot of benefits from the safety viewpoint. So we will get rid of the driver errors when the vehicles are concentrating only on driving and monitoring the environment. And also we are able to provide equal transportation modes for everyone. So also people who don't have driving licenses or access to their own private cars. But then, of course, when we are talking about collecting a lot of data, we are then addressing some challenges that we really have to take care of. And this is what we will be talking about in the panel also. So we have to ensure that the data is available for everyone and for the use of the artificial intelligence methods. And then we have to be able to get fair ways of sharing the data. Then also, when we are collecting the data from the users, we have to make sure that the privacy of the users is protected and that we are not using biased data and then thereby making biased decisions. So there are many technological things that we have to address when developing the artificial intelligence for enabling the future smart and sustainable mobility systems. So, for example, the systems, and definitely when talking about autonomous driving, require very reliable perception and navigation. But then again, we are talking about challenges that when we are talking about navigation in the areas where the smart mobility is most used inside cities, we are not really having good use of the traditional navigation systems, so the satellite navigation solutions, because they don't really work in urban areas and are not at all in indoor areas. And then still we have to provide the seamless navigation and access to location data for the smart solutions. So it is envisaged that in the future, so the navigation and perception of the mobility system, so they will be based on fusing data coming from various sources. So for example, using the satellite navigation data, but in addition to it, different optical systems and computer vision methods, 5G signals, for example, other radio signals, and then sensor data. And then also some challenges are caused by then the users of these mobility systems. So we also have to provide good ways of navigating and perception for pedestrians and then, for example, bicyclists also. And then we, of course, require very small and lightweight equipment. So then in the future, kind of the key is to then fuse all these different data adaptively from different sources. And then for that, for example, artificial intelligence is giving really good means. And then we can use, for example, deep learning then for fusing the data coming from very different sources. And then also when we are then having the vehicles equipped, for example, with the cameras and using the computer vision methods, we are then also able to understand the environment and then get information about the environment by using artificial intelligence. So in our research group, we are, for example, developing deep learning methods for so-called three-dimensional object understanding. So when we are talking, for example, the autonomous systems and other smart mobility systems, so we really have to understand what are the objects in the environment. So for example, is there a plastic bag coming in front of our vehicle, or is it a human that we have to really take care to avoid of not crashing to? And therefore, we have to develop sophisticated methods for then understanding what the objects are and also where they are located with respect to our equipment. So for example, our vehicle. And then the 3D object understanding, it joins different computer vision methods. So detecting what objects there are in the environment, being able to track those objects, how they move, and then also get their location with respect to ourselves. But then again, when talking about then the future smart mobility, so in the future, we most likely will also have a bit more atypical transportation modes. So for example, the drones flying around in the city. And then we also have to then address situations when we have quite atypical perspectives that will then again complicate the situation even more. And on the bottom, we can see an example of our research project where we have been developing 3D object understanding for a crane, so having a bird eye view for the environment. Well, one of the great things with artificial intelligence is that we are able to fuse very various data. And that fact we are using in our project called Couscous, where we are doing interdisciplinary research and joining information about air quality, socioeconomic population forecasts, and then traffic modeling. And the goal of the project is to provide for the city planning advice of how these things should be balanced for getting the optimal situation for the cities. And in that project, we are then addressing the traffic modeling. So how are we able to model the traffic accurately and do, for example, dynamic routing there? So traditionally, the traffic modeling has been looking at a very limited number of variables. So for example, addressing the season, when the traffic is experienced, looking at the time, for example, if it's daytime or nighttime, different events affecting the traffic, and then also looking at, for example, the weather situation. But to get really full understanding of the traffic and being able to model it accurately and getting information for the dynamic routing, we have to address all these variables at the same time. And then therefore we are then developing deep learning methods for then looking at all these different variables at the same time. And then to be able to then join all this different information coming from these different viewpoints, so the air quality, socioeconomic modeling, and the traffic modeling data, we are using a method called reinforcement learning. So in reinforcement learning, we are trying to teach agents to take some actions and monitor how these actions then affect the environment. And then by trying to maximize so-called joint reward function, then to being able to optimize the situation. And at the end, to provide then good information for the city developers, for the decisions makers about how to then balance these different aspects to get good situation for the cities.